This is a tool that I use to help visualize the information needed to calibrate a base map. In this case, it's a base fuel map and a HEFI. Since it's much easier to visualize measured data relative to a curve instead of a surface, when you're viewing it on a computer monitor, the basic idea is to dynamically slice the surface from two different directions and then add in the measured data that's close to the plane that you're using to slice the surface. It sounds complicated, but it's a way to take a dimension out of the problem. And looking at the slices from two different angles simultaneously can help you visualize the shape of the curves and fill in the gaps or extrapolate more intuitively. So what this tool does is it finds points for multiple data logs that you're close to what you're looking at. It filters out the rest, and then it plots the data from the logs with the data from your map in an apples to apples context. So you start by loading a calibration. I'll load one that I was working on recently. So you see it changed the base map here, and this is the base map. It should just look like it does in the HEFI software. In this case, the y-axis is map for the load indicator. The x-axis is of course engine speed, and then the table itself is VE. And then you load your data log or data logs. I'm going to load one at a time. You can load all of them in a given directory, which is kind of handy, but I'm just going to load one that I was, again, working on recently. So it will spin here for a second and load. Okay. So the XY plot here is showing you how you filled out the space of the map. The white dots represent the calibration points in the base fuel map on the X and Y support points. And the red dots are where the engine went in the data log that you've loaded. Obviously, to get a robust calibration, you need to cover as much area as possible, or more to the point, the area that the engine will cover in normal operation. So over to the right, we have XY plots of measured data over the calibration data. The top plot is a line of constant RPM. So imagine that you chop the base fuel map right along this blue line and then turn it so you're looking at it perpendicular to the cut. And the blue line here is the section of the map that you just cut, and the red dots are all the points from the data log that are close to the cut. So in this case, it's VE versus map at 2000 RPM, and the red dots are points from the data log from an RPM of 1905 to 2095. That's the window, and you can adjust the selectivity here if you want to. If you have sparse data and you want to have more of a context of what the shape of the curve looks like, you can increase it. If you have a lot of data and you want to get really close and figure out exactly where the points are going through, you can increase the selectivity. And the bottom plot is the same thing, except this time what you're doing is you're looking at it along this direction. So the green line here corresponds to this green line, and it's basically at one load or one manifold pressure, and then the x-axis here is engine speed. And again, you're looking at the red dots are from 64 to 68 kPa, and again, you can adjust the selectivity, to if you want to open it up and look over a little bit broader range, you can increase that, or decrease that to try to be more precise. So moving the focus and the base map automatically changes, it updates which blue line here you're slicing from. So as you move this along, you can see going at lower speeds, 1750 RPM, 1750 RPM, going up at higher speeds, 57. As I don't have as much data at the higher speeds because I didn't spend as much time at the higher speeds. So you can see that there's a little bit more densely packed data at the lower speeds, but up here at the higher speeds, for instance, at say 6,000, you may want to increase that or decrease the selectivity increase the window over which you allow the points to be visible. So that helps you sort of at a glance run through the entire base map and look at where you are relative to your actual measured data. And in the same way, you can move the line of constant load up or down, and it will automatically filter out. You can see the bottom graph changing. So this is centered at 28 kPa from 24.5 to 31.5. So the red lines are where the engine wants to be or has been, and the green line is what you have in the map. So in this case, you can see there's obviously an offset between where the engine was and what you calibrated. So what you can do, you can either drag with the cursor here, or you can just mouse over a point, get in the right spot, and use the scroll wheel, and that will move your calibration point. See, it's moving the data here in the yellow line, or in the yellow box, sorry. And what's interesting here and what's useful is that when you get it in line with the shape of the curve in this graph, you see that it also lines up with the shape of the curve in this graph. So that's one of the keys to being able to look at both of the slices simultaneously, because if you have a complete gap and coverage in one, you can use the other one to visually extrapolate, or to visually put in context where you should be. And here, there's a fairly thick distribution, so I'm going to increase the selectivity to try to make it more obvious. So you can do the same thing in this graph. If you mouse over here, it changes the focus, and you can move that up or down. And again, you see when you get it right in this graph, it's automatically right in that graph. And if it's not, that's because you probably have some bad data. So anyway, you can move these along. You can do it by hand, or you can throw out some of the outlier points and then do a fit with the automated tool. But that's the general introduction to the sort of first page of first tab of this tool.